Okay, let's get started with EasyC-V4 for the VEX Cortex. First thing you're going to do to create your program is click on New Competition Project and then just click OK. Here on the top you'll see 4 different tabs: Main, Initialize, Autonomous, and Operator Control. Just leave Main and Initialize alone. You'll be working only in Autonomous and Operator Control. Up here we have 2 very important menus. The controller configuration menu, where you configure your analog and digital inputs, and in the case of digital outputs, and the motors. So over here we have all of your sensors, and if you just click on this and start typing, you can name your sensors. Same thing goes for motors, so we're just going to create a standard motor configuration. We'll do a 2 motor drive, a lift and a claw. So right drive, left drive, lift, and a claw. The motor type you don't have to worry about, it's just for your personal reference, so you could set it to something like integrated motor encoder. IME is a type of sensor that's built into the motor, so if you want to remember that this one is an integrated motor encoder, then you would leave the motor type as integrated motor encoder. Or if you wanted to just remember that it's a standard or a smaller motor, then you'd set it to that for just your reference. So over here in the function blocks we have a bunch of drop down menus: program flow, inputs, outputs, joystick are the ones you'll be using. Battery is also useful. You can retrieve battery voltages if you're using an LCD screen and display them. So just so you can see your battery output. We did that on our robot this year and it worked really well, but as of right now not everyone has an LCD to use. So joystick takes all of the inputs from the driver through the joystick and has built-in functions to control it. Tank and arcade, the difference here is really personal preference. Tank uses both analog joysticks, just the forwards and backwards channels to control the robot, and it drives it like a tank. Arcade uses only one joystick, and when you push it left or right, it moves the right and left drives forwards and backwards respectively to turn it. So we're going to use tank. We only have 2 drive motors, so we select tank 2 motor and drag it over here on this line inside the while loop. This is a continuous while loop here, so anything that you want to keep running you have to put inside this while loop. Drag that over and you'll see this pops up, which allows us to really easily configure this function. So the joystick, number 2 is a partner joystick if you're using one. The channels you can see on the joystick. So our left forwards and backwards channel is 3 and our right forwards and backwards channel is 2, and those were already in here. If we needed them to be different, we would put them in differently. So you'll see here for left motor, if we hit this drop down menu, we can see all of those comments that we put in the controller configuration menu. So for the left motor, we're going to go ahead and select left drive. For the right motor, we will select right drive. And then these invert directions. If you guys have seen the wires, I like to plug my wires in metal to metal so that they're facing the same direction. The red wire goes to the red wire, the black wire goes to the black wire. And some people like to switch them around manually, like they program it and then they switch it to see if it works. I like to go back into the programming and, like, if the left motor was turning the wrong direction, just turn this to a 1 and it will invert it. You can see in the drop down menu here too, it has 0 and 1. and then any variables will show up in these drop down menus too. Any variables that you create, or you can type in variables here. So we'll just go ahead and hit OK on that. Actually, I'm going to switch this to a 0 because I don't think it will be inverted. So then what we're going to do next is get button values from the joystick to control the lift and the claw. For that, we are going to use joystick digital to motor. This will allow us to control the claw in two different ways. So joystick 1, channel, we're going to look on the front of the joystick and we see the left channel. I think we'll use to control the claw, that is number 5. And then button 1 and 2, you can see on the right here, down is 1 and up is 2. So down right now will give us a positive motor value, which is counterclockwise spin, and button 2, the up button, will give us negative motor value, which is a clockwise spin. And then the motor here we will set to the claw. And in the comments section here we can type what this block does, so we'll put claw. And then here you can see the comment. I always recommend making comments for everything in your code, just so you can look in and see, because they all look the same. So this way you can look and see this was the claw and this is the lift, and so on and so forth. So what we're going to do next is go into the program globals here and create a couple variables to control our lift. So under type here, if you hit this drop down, you can see a bunch of types of variables. The only ones you really need to know about are int, which is short for integer, and char, which is short for character. So if you're putting numbers in, use integer, and if you're putting a word or letters in, use char. So we're going to do numbers, so we'll select integer, and then we'll type a name for it here. It's really important to make a name for your variable that makes sense. So for our lift, we're going to control it with the right buttons, which is channel 6, and the front ones we call the trigger buttons, and there's an up and a down. So I'm going to put right trigger up, and we'll leave the value blank because we're going to set the value from the joystick. And then the comment, we don't really need a comment here because my name tells me exactly what it is, but if it was more ambiguous, then you'd put a comment here that tells you what the variable does. We'll create a second one, call it right trigger down, and again we'll leave this value the same. So naming variables, it's important you can't put any spaces in the variable. It all has to be the same. So what I'm doing here to make it really easy to read is called camel case, where I'm capitalizing the first letter of every word. You can also put underscores or dashes in between them. Actually no, you can't do dashes, never mind, that subtracts. But you can put underscores in between them to separate the words. I like camel case personally, but that's just a personal preference. So we'll click OK here to finalize those variables. And those are global variables, which means they can be used in any function. So now what we're going to do is retrieve the variables so that we can use them in an if statement. So we're going to use this function here, get joystick digital, to get the digital buttons. Joystick 1 channel, so right trigger button, so 6. So 1, we'll see, is down, so we will retrieve it to these variables we created for right trigger down. And we don't need a comment here because you'll see in the code on the screen it will display right trigger down is equal to get joystick digital. So we can see that's retrieving the value for right trigger down. Get a second one here and do the same thing for right trigger up. Click OK. And now these two variables will hold the values of the buttons. There'll be 1 when the button is pressed and 0 when it's not pressed. Go into program flow here, select an if statement. So we'll do if right trigger up equal to 1. What this will do is it will take the variable right trigger up and check if it is equal to 1. In programming, you use a single equal sign to assign a variable to something, kind of like in math, but to check the values to see, like, oh, is this equal to this, you use double equals. Under the operators, you can see there's a bunch of operators. Probably won't use very many of them. And or right here allow you to check different things. So if I was going to say, like, right trigger up is equal to 1 and like the left trigger up is equal to 1, and then I could put both of those in the same if statement. Okay, so now we're going to use this else if, which is a combination, you can see the else and the if. So else tells it what to do if the if statement up here returns false. So else if right trigger down is equal to 1. Hit OK here. So if the up button is pressed, do this. Otherwise, check if the bottom button is pressed. If it is, do this. And then we're going to get another otherwise, do this. So what this is going to allow us to do here is to give our lift a small holding power. There's two things you can do with lifts. You can either put rubber bands on them so that it perfectly counteracts gravity at every single point on the lift. Or you can give it a small power to hold it up. We call it a holding power. Anything about 10 or 12 or 8 will work. 8 will work perfectly for a light lift, 12 for heavier ones, but keep it around 8 or 10. Any more than that and your motor will start overheating and it'll shut off. Outputs here, see this motor module, which allows you to directly set the power of a motor. It's important to note on these that once you set it, it will keep that power until you set it to something different, like 0. You'll see it stop. So if you want to stop, you have to set it to 0. We don't want the lift motors to stop. We want to give them a small power. Let's say the up on our left here is counterclockwise. So we'll give it a positive value. You can see it says counterclockwise right here. We'll just check that box. And let's say down is clockwise, and we can check this box. But a lot of times you don't need as big of a down power as you do of an up power. So let's check this user value here, and we'll put in -80. So that way our lift won't come crashing down on us. Then here at the bottom, we'll give it a small holding power of 10. So now, if we press the up button, the lift will go up. If we press the down button, the lift will go down. And if nothing is pressed, it will stay put where it is with a small holding power. Now this is only if you have one lift motor. Obviously if you have 3 or 4 motors on your lift, you're going to have to put 3 or 4 of these in here, each set to the motors. Oh, and I forgot to set the motors numbers. So we'll go down and select lift on all of these, which is port 4. And again, just notice if you put a good comment in the controller configuration, it's really easy to choose which ports that it's plugged into, because it's right here and you can look in here and it says lift. Alright, so in this if statement we're going to put a comment and we're going to say lift controls with holding power. Hit OK there, and you can see it shows up right here to keep our programming nice and clean. What we're going to do now is we're going to move all of this here to control the lift out of the main while loop here, so that we can have room for more code and we can easily see what's going on. So for that, we're going to create a user function. We're going to go ahead and right click on this and hit add new function. The return type, if you're doing math or retrieving values from sensors or something, you have to return a certain type. These are the same types that our variables are, so if you create a variable to return it, it has to be the same type as that. You probably won't have to worry about that, but if you ever get to where you need to use this return type, there's this help menu right here, and it'll tell you all about this function. And also, if you ever forget how to use any of these, there's a help button on every single one of these. Name here, we're going to name our function lift, and arguments are like variables that you can send to the program, and they'll become local variables inside the program. We're not sending any arguments to this particular one, but in advanced programming you use a lot of arguments. Comment, just put controls the lift. Difference between the comment and the description is that the description can only be seen in this window, and the comment shows up right here at the beginning of the function. You can get to that window again by double clicking this begin, so you can add a description or view the description that you put, and you can create local variables inside here. Local variables are only available to this function, so if I created a local variable here, I would only be able to use it inside the lift, and these global variables here can be used anywhere. And really, since we're putting these in a function, these right trigger up and right trigger down could be local variables if we want them to be, but you might use them for something else too, so there's no harm in leaving them global variables unless you want to use the variable name, like if you wanted to have a variable called number and you wanted to use it in 3 different functions, you'd want to make them all local variables. If any of them was a global variable, it would start overwriting the other ones. So in here, we're going to go click on this, scroll down, and shift click on this very last else block. And you'll see check to make sure all of these are selected. Right click and hit cut. You cannot use the Control C and Control X and Control V in this program, which I think is really annoying, but that's just how it is. Go into the lift here, right click on this thread here, and click paste. And you'll see all of this is pasted into our function. But our function isn't being called yet. You call a function, you drag it over into the chain, and you can see you could put any of the arguments or the local variables that we were talking about, and here you can comment again. We don't really need a comment. It's called lift, so you can probably figure out that it controls the lift. Alright, so now we have this basic program which would allow you to control any simple robot such as your Clawbot. So there are a couple things that I forgot. First of all is build and download. Compiling is included in the build and download, and compiling just translates all of these little blocks here into ones and zeros that the robot can understand. And if you look up here, you can see it's F7. So if I hit F7, or if I click that, can see it begins the compiling process, and then it asks you, would you like to download the program? If you hit yes, and you have a Cortex plugged in via the orange programming cords, and you click yes, and then it will go to this screen and attempt to download the program. I don't have anything plugged in, so it's not going to do it right now. Also, there are 2 power banks in the Cortex, 1 through 5 and 6 through 10, that route the power to the ports. So when you're wiring them with Splitters, which you'll probably use when you start building bigger robots because we don't use ports 1 and 10. Be sure to balance them. So if you have 2 splitters on your Cortex, run one of them off the first power bank, 1 through 5, and run the other one off 6 through 10. If you have 4, run 2 of them off of this power bank and 2 of them off of this power bank. Try and keep it balanced so that you don't have too much power draw through one circuit or the other, because you will also fry the Cortex. Do not plug anything into ports 1 and 10. The circuits that are the motor controllers are embedded into the Cortex for ports 1 and 10, and you can easily fry them. Do not plug anything into ports 1 and 10.